as well.
Great. Okay, so I'm Ben Glick. I'm also known as Parsl's number 3 Ben. Um, and I'm going to be talking about Parsl as a gateway for research computing. So this is a little bit different than anything we've heard because it's not really, I did something with Parsl. It's this is how we use Parsl to sort of simplify our lives as operators of a cluster / research computing office. So Okay, so I am a recent graduate from Lewis and Clark College, which is a liberal arts college in Portland, Oregon. I graduated in May, and while I was there, I helped to found a small research computing office. We acquired a cluster during my time there, which is pretty small. It's something like 10 nodes. It's fairly heterogeneous. So we have some nodes with GPUs, some nodes with fast storage, some nodes with big memory, things like that. Most of our time is spent dealing with and helping people teach using our cluster. During the summers, we get a lot of students and faculty doing research, but during the school year, it's mostly used for teaching purposes, which creates a kind of different and strange variety of workloads that end up needing to show up. And we have these strange situations where we have all of a sudden 100 people trying to run a copy of the same job and our cluster gets overwhelmed. And then other times where it's just idle for weeks. So it's a little different than what a lot of the other stories we've heard today and yesterday. And then also we have this extremely limited support issue. So while I was in school, the official support for our research computing office was 1/4 of one full-time librarian and 1 student salary, which was me. And so now that I'm gone, I actually have no idea what the official resourcing is. But so we still have that 1/4 of one full-time person, and then I'm still sort of helping out every now and again. So just real quick, I wanted to just give people an idea of what kinds of things we do. So we have a group that does computational statistical mechanics to try and understand the strong nuclear force better. So they have a lot of sort of Monte Carlo simulations and, differential equation solvers and things like that. We have some groups that are doing AI type things. So a group that's doing, trying to take pictures of the sky and measure things about clouds. We have some groups that do work with phylogenetics. So specifically one group that does work with spider evolution. So they take, transcripts of whole spider genomes and also spider venom proteomes and things like that, and try and figure out how evolution is happening in this specific kind of family of spiders in southeastern Australia and New Zealand. And then we have some people doing HPC education. So we try and teach people how to use our cluster better. But that has mixed results. So basically our problem is a little bit different than most of the ones that we've heard today. Our issues are mostly lack of experience and usability issues. And then we don't have any time or resources to support. So for example, if we have a bunch of biology students who are logging onto our cluster to try and create trees of evolutionary trees as part of their phylogenetics course, we have to teach them how to use a command line. We have to teach them how to submit jobs to Slurm. We have to teach them all sorts of things that we just really don't have time for in a 15-week semester when they're also supposed to be learning biology. So yeah, the issue is really just how do we support this with our limited resources, and how do we support it in a way that doesn't get in the way of education? And so our answer is to use Parsl as infrastructure. It makes our lives so much easier as cluster operators and as people who are in the classroom helping out if we can provide Parsl as one endpoint for people to interact with the cluster with. So the vast majority of our users simply do not log into our cluster ever. We have a library of Parsl configs. We have a library of example scripts that are, so we have a scatter gather one where it's like, paste your code here for the scatter step and then paste your code here for the summarize step. And then it will just sort of run it on our cluster without any problems. We also have recently started supporting FuncX. So we have 5 or 6 different FuncX endpoints. So we have, things like small, medium, large, which is just some number of CPU cores. We have a FuncX GPU, which provides one CPU core and a reservation on a GPU for our AI people. And then we also have this Jupyter Hub spawner. So we have a Jupyter Hub running on our cluster login node, which uses Parsl to spawn jobs on the on worker nodes, so that if you're a student and you just want to write code, you can go onto Jupyter Hub and you can just write Python code and it will run. And if you want, you can use Parsl types of, you can decorate your code with Parsl apps and stuff like that to add some extra parallelism almost for free. And so basically, excuse me, doing it this way has allowed us to just basically present a serverless interface towards our own cluster for our students. And obviously from an administrator's point of view, I mean, the administrators are still, we're still responsible for installing software, making sure the operating system's up to date, making sure, networking is all right, but we don't have to ever help our students deal with that. And we don't ever have to help our students deal with Slurm scripts and things like that. And it's made our lives much, much easier. Okay, so moving on to some things we love about Parsl and some things we would love from Parsl. So we really love the level of abstraction. Basically, I'm able to provide Parsl and FuncX configs for students and they can just use them. And I can mess around with the cores per worker, and I can mess around with the blocks and how they're arranged and stuff like that. And I can add Slurm options, like I want this job to have 1 million hours of wall time, or I want this job to use a ton of memory or whatever. And that is very easy for me to deal with because I can just present it to my users as a little Python script. I also love being able to just interact with Python for the actual debugging of student workflows. That makes my life a lot easier. I've already mentioned that. And I really like being able to provide FuncX. So FuncX has allowed me to give students an endpoint and then let them run with it. And they'll come to me for help, but basically they can understand how to use it, which I think is really cool. And then the 2 things that I would say I desire are, I would like to be able to interactively manage a workflow without killing it. So if I'm one of my physics users and I have a weeks-long workflow that they haven't optimized to happen in many steps with checkpointing, I would love to be able to press pause, change parameters, and press play again. And then I would really like to be able to transfer tasks across pilot jobs. So if I have a job which is about to hit its wall time, I'd love to be able to just have it automatically go to a new pilot job without, losing anything. And that's probably a little bit of a pipe dream for a number of reasons, but yeah. Okay, so in conclusion, Parsl makes my life possible, and I really appreciate it. And thank you to the Parsl team, and thank you to all these people at my school. And please let me know if you have any questions.
Great, thanks. Does anyone have a question?
I do. Hey, Ben. Thank you for your talk. This is amazing. I have 2 quick questions. One is, do you have an estimate of how many users might be using the system with Parsl?
How many users at any given time, or how many users total?
Total, and at any given time.
So total is something on the order of a few hundred, something like 200 or 300. And at any given time, I don't think I've ever seen more than 50 or 60, but
okay.
There's no reason it wouldn't be higher. The only thing is that it's a small cluster and we can't support that many jobs at a time. I mean, they would just wait in the queue for a long time if there were more.
Is there any chance, Ben, that you could turn on usage tracking by default for some of the templates you give your users? We'd love to.
Yes, I can do that.
You might want to tell them that you're doing it, but
yeah, obviously. But yeah, I can do that for sure.
The second question is, so you mentioned that you might want to have tasks that fail automatically move over to a new executor with a fresh job to run it. So would you be okay with setting retries to be greater than 1 so that if if a task fails, it automatically gets rescheduled for execution somewhere else.
Yes, I can do that. The thing that I would like is if I could, in combination with the other thing I had talked about, if I could, instead of retrying it, if I could pause, move, and then restart, so that
Okay.
so like I have some students and faculty that have like a job that's going to run for a week and it's not saving anything, and that's bad design, but I can't make them design it better. And so I would love to not have it get wall timed out and then they have to restart their whole week-long thing.
Right.
And use up all my GPU time.
And we should talk about this after.